We are now on number 2 of June 2014, paper 2. So number 2 starts with a picture of the periodic table, and there are some elements X, Q, and Z on the periodic table. Based on the position of element X on the period table, state whether it would react more vigorously or less vigorously with water than K would react with potassium. All right, so if you look here, X it belongs to group 1. All right, so all elements in group 1 contain one valence electron. So take a look at it here. All right, so potassium is this one, and okay, so X is just under potassium. So if you look here, under potassium, we have rubidium, right? So let's look at the sizes of them. If you notice, they both have one valence electron. However, the distance between the electron and the nucleus is different. The reason being, rubidium has more shells and its nucleus is more shielded. Therefore, this electron is less attracted to this nucleus than this one. So rubidium can lose its electron a lot easier, or it can be ionized easier compared to potassium. And when something can be ionized easier or lose its electron easier, we say it is more reactive, right? So would it react more vigorously or less vigorously with water than K? It will react more vigorously because it is more reactive than potassium. Would the solution form from the reaction of X and water be acidic or basic? Well, it will be basic because from what we learned from metals, metals plus water will give you metal hydroxide. And metal hydroxides are basic or alkaline. All right? So the answer is explained here. X is a metal. When reacted with water, it will form a metal hydroxide, which is considered to be basic. Write the electronic configuration for magnesium. All right, so let's go to our chart again. Magnesium. Okay, so we're looking at this one here. Magnesium has 2 in the first shell, 8 in the second shell, and 2 in its outer shell. So that will give us an electronic configuration of 2, 8, 2. It contains 2 valence electrons. It belongs in group 2, and it can form a 2+ cation. All right? Based on the position of element Q, write the formula for its carbonate. So let's look at Q. Right? So Q is right under magnesium in group 2. Anything in group 2 has 2 valence electrons and will form a cation of 2+ charge. All right? So our Q cation will be 2+. The carbonate and ion is CO3 2-, and the top charges, because they are the same but oppositely charged, they can be cancelled, right? So you end up with Q CO3. Write a balance equation for the reaction of the carbonate of Q with hydrochloric acid. Firstly, you must know what your products are before you decide to write this equation. So any carbonate reacting with hydrochloric acid is going to form a chloride salt, carbon dioxide, gas, and water, right? So we have QCl2 plus water plus carbon dioxide, and here all we do is just, it's already balanced, right? So we have 1C, 1C, 3 oxygens, and so on, right? So that is basically balanced. Right, next question. Sodium reacts with element Z to form a compound. State whether this compound is ionic or covalent. So let's look again at Z. So Z belongs to group 6. Sodium belongs to group 1. Right? Good. So, if sodium belongs to group 1, right, it's going to form a +1 cation. Z belongs to group 6. Therefore, its ion, right, it must be able to accept 2 electrons for a full stable octet. And by accepting 2 electrons, it gains a 2- charge. All right. We then cross multiply, right, by the charges. So this 2 comes here, and this 1 charge comes here. And then we end up with Na2Z. Okay, so this is definitely an ionic compound because it involves the transfer of electrons. So sodium must lose an electron and Z must gain that electron. All right, there's no sharing of electrons here. It's strictly gaining and losing electrons, and that is what gives us an ionic compound. Next question. Calcium nitrate decomposes under strong heat according to the following equation. Right, so we're given this equation. What visible change would be observed when calcium nitrate decomposes? Here they are asking us what we are going to see when this is burnt or when this is decomposed under heat, right? So nitrogen dioxide gas is one gas that is released as a result of the decomposition of calcium nitrate. This can be easily identified as a reddish brown gas. All right. I could also mention that if you place a glowing splint into the test tube, it will rekindle with the oxygen. However, they did not mention that. They are just asking us what will be observed when it decomposes. This is the only thing that you will be able to see. Okay? Next one. 5 grams of calcium nitrate are decomposed completely. Calculate the volume of NO2 produced at RTP. So look at this. So we are using this equation, right? We are using 5 grams of calcium nitrate. We want to know how much nitrogen dioxide will be produced by using 5 grams. So first thing we have to do is to find the number of moles of calcium nitrate in 5 grams. All right, so number of moles equals mass over RMM, which would give us 0.03 moles of calcium nitrate. Now we have to look at the molar ratio. Here it's shown that 2 moles of calcium nitrate will form 4 moles of nitrogen dioxide. So it's a 2 to 4 ratio, right? We can further simplify that to say 1 mole of calcium nitrate will form 2 moles of nitrogen dioxide. What do we have in our experiment? We have 0.03 moles. So if the amount of nitrogen dioxide is doubled, right, then we will get 0.06 moles of nitrogen dioxide gas formed. So the second step is to find the number of moles of nitrogen dioxide. Now they are asking us for volume. So for volume, we know that 1 mole of any gas occupies a volume at RTP of 24,000 cm3. All right, so we know how much volume it will take up if it's 1 mole. And how many moles do we have? We have 0.6 moles of NO2 gas. So 0.6 moles will form 24,000 times 0.06, which will give us 1,440 cm3. Right? And that was a pretty simple mole calculation. The more you can practice, the better for you. All right? So that is it for number 2.